Okay, so guys, we're on page 45 of your notes. Now, today we're going to deal with problems that involve more than one right triangle, or triangles that are not right. If it is not a right triangle, then somehow we need to make it a right triangle. So we have to add a line and construct a right triangle. So for example, if you have, and I told you, okay, you have an isosceles triangle where the equal sides are 5 centimeters. What's an isosceles triangle? No. Yeah, so a lot of you said that two sides are the same. So the equal sides are 5, and say there's an angle of elevation of 40 degrees. That means this guy is 42. Now, is this angle up above going to be a 90 degrees? Do these two add to 90? No. It'd be 100. Okay? So how would I... No, Lena, you need to take that out of your ear. It's okay. How would I make this a right triangle? Yes?
You could add a line straight down the middle, and then there would be a 90-degree angle at the bottom.
Make it straight down. It would cut exactly in half. Yeah, we'd have two congruent triangles. And then could I find, say, the base by finding, we could find this little x here, and then when we get that answer, what would we do? Double it. Exactly. Okay? So if it's not a right triangle, we have to make it one. Okay? A common mistake is students would actually, if they're looking for the base, they'd do this. Opposite, adjacent, I'm going to use tan. It doesn't work for if it's not a right triangle. You won't get the right answer. Okay? It's a common mistake. Okay, so when we're dealing with a problem like this, we need to find the right triangles that are involved. Do you see more than one right triangle here? Yeah. Now we're looking for length AD. So this length AD, I'm going to call it X. That's what we want to find. Okay, so on the right triangle, do we have enough information at this point in that right triangle to find it?
Not that specific one.
Not that specific one, because you need to know two pieces of information. You either need to know two sides, or you need to know an angle and a side. Always at least a side, though. If you have all your angles, can you find a side? No, because it'd be similar triangles. We don't know, right? So you have to have at least one side. So can we find out, is there a side in common with these two right triangles? Yeah, what is it called? In between the AC, okay, I'm going to call this y. So we're going to solve for y first. So according to triangle ABC, what's 18 going to be?
18.
The adjacent, and y would be the hypotenuse, okay? So which ratio will we use for that triangle? Ka. You got it, ka. Cosine. So cos of, what angle do we have? 30 equals A over H. 18 over, I called it Y. Or you can leave it as H, it's up to you. I called it Y. Okay, what's the shortcut when Y is on the bottom? Okay, you multiply both sides y and then divide. So really what happens is these switch.
Oh, so this is the beginning of the right triangle spiral.
The old switcheroony. We're going to have division when y is on the bottom, or our variable's on the bottom. Okay. Now, my question to you, are we going to round this answer? No, it's not our final answer. We want to keep it exact. Well, the final answer to 2 decimal places. So it's important when this number comes up in future calculations, we'll have to use that exact value. The whole thing. Because otherwise, especially if you're rounding your final answer with 2 decimal places, if you don't, and you only put in 20.8 instead of 20.78, blah, blah, it can actually change your answer and you'll get your rounding wrong. That happened to a bunch of people in the quiz today. Okay, they used a rounded answer in future calculations, and then their whole answer was off a few decimal places. So that's why. Okay, so .78 dot, I can write down 78 for now, but we're going to use the exact value in our future calculation. Okay, so now we know this is 20.78. Can we find x now? Yes, so with this new triangle, what is side 20.78? Opposite. It's opposite the angle. It's hard to see, but it is opposite the angle. And what is x? Is the hypotenuse. It's opposite. It's across from the 90. Okay, OH. What has OH? So, ka, or toa? So sine of 40 degrees equals what over what? So opposite. Okay. Because it's on the denominator, we're going to do the switcheroonie. So 20.78 all over sine 40. So when I type this into my calculator, here's the nice thing about your calculators. We don't have to actually type it all in, because if it was my previous answer. So if I just push divide, it automatically goes answer divide. So answer divide by sine 40, and our answer now to 2 decimal places. Just push the division symbol, and it automatically does answer divide.
I wish I had done that before I kept pressing second answer.
Yeah, you could do a second answer, second negative to get answer. Or if you just push division, like say I wanted to take this answer and times by 2. If I just push times, it automatically does previous answer times. Okay? So 32.3, what? 34. 32.34 is our length of AZ. And there's meters. Forgot my units. Your units. Okay, so the key here was don't round. I just combined don't and round to downed. Don't. Yep, it sure is. And the Friday after service days too. Makes us all a little extra tired. Right? We want to use the exact value in our calculations because it wasn't our final answer. Where's your notes? Get them open, Anthony. Okay. Let's look at the next guy. High. Find high. HI. Side HI. To 2 decimal places. So this is what we're looking for. Okay. Sorry about my rectangle or my squares. They don't look very squarish. But those are right angles. Okay, so we need to find side x. Now, we know a side in that triangle, but do we know enough information to find that side? If we figure out this angle, we know that one, but this is not a right triangle. It's a 95 degree. This isn't a right triangle, so we can't use that, we can't construct that triangle, which is students will commonly do. Yeah? Okay, the left triangle, what would you need to find out in the left triangle? The angle here. Okay, so that angle, if we find out that angle, could we figure out this small angle here? Yes, because a straight line, what does a straight line add to? 180 degrees. Right, so we need to find that theta there. So in this triangle, what are we going to use? What do we have? Tan. We have the legs of the triangle, not the hypotenuse. I don't know. I can't even do it like the video. Sorry. So just ignore me. Yes. Get tricky with it. Na 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 na. Just Google on YouTube or go on YouTube and get tricky with it. Oh. So glad you're paying attention. That's how I chat. Okay, we have adjacent and opposite. We have the legs. When we have the legs of the triangle, we use tan. Tan of our unknown angle equals Opposite over adjacent. So 23 over 14. How do we get our angle when we have the ratio? Inverted. Up. You with me? Okay, inverse tan of the ratio. Okay, are we going to round this answer? No, it's not our final answer. So keep a couple of decimal places. All right, 43.78. Dot, dot, dot. Oh, thank you guys. It's just obviously one of those days. Somebody needs a map. Okay, so did you get that number? Okay, good. So we have 58.67 dot, dot, dot. Okay, so now how can we get, I'm going to call this angle beta. Often if theta is being used, we can use beta. Or theta what? Theta 2? The other one. Okay. Theta or beta, it's like a B with, no, it's like that. With an extended line here. Okay, that's beta. It's another Greek alphabet, often used for an unknown angle. It's good to get to know this stuff because when you get to physics, they use a lot of these Greek letters. Physics is full of Greek letters. Guys? Okay, how do we get beta? This was actually 23 over 14. Yeah. Yes. Yeah, so we have 180. We're going to take away the 95 and our 58.67. Or add those together, then subtract. Either way, so you're welcome to go add to 95, add the 95, and then 180 minus second negative, minus my answer. So beta is 26.33 approximately. But we're going to use the exact in our calculation. Okay, so we finally know I'm going to replace that here with 26.33. Can we find? Yes. Now we know an angle and a side. So in this triangle, what is side X? Opposite, and we have adjacent again. We have the legs. So we're using tan. Tan of what angle? 26.33 equals X. So when X is on top, we're going to multiply both sides by 27. This is a multiplication. Easy peasy, right? Lemon squeezy. So 27, so instead of typing this all out, I go 27 tan, and then second answer. Instead of typing out that full angle again. Oh, I love this calculator. So much better than those old school ones. Okay, so 2, how many decimal places? 2, 13.36. Coulomb. No, there's still a couple ones I need to look at with you. The word problems that are definite test type questions that maybe we haven't seen before. Yeah? Oh, beta? So it stands, when theta is used, it's a Greek alphabet that's often used for an unknown angle. So again, it's another, same idea as theta, but if theta is already, we already use theta, I don't want to confuse the two, so I use beta. Yeah. Okay, we're actually going to skip the next guy, but let's just talk about strategy. Answer is 53.33.
Yes.
Okay, just quickly, what strategy did you use to solve this before we, what strategy did you use? Okay, Taylor? Yeah?
So for KLJ,
Yeah.
one angle, we subtracted 52 plus 90 from 105.
Okay, so you want to figure out this angle right here?
38 degrees.
Okay, so 90 and 52, we know what our triangle adds to 180. So she's saying, okay, if I add these together and subtract from 180, that gives me this angle, which is 38 degrees. Yeah, and so now that she knows that, you did 38 from 105. And what did that give you? 67 degrees. Okay, so okay. So you have two parts here. You want to find this full length KM, so you have to find LM and KL on your two separate triangles, and then add them together, right? Okay. So you'd have to break it up into your two right triangles. This full length you can't find. It's not a right triangle, the big triangle. So you have to break it into your two smaller triangles. See, the reason why she had to go through all this is this triangle, we didn't know one angle. We need to know either this small angle or this small angle. And without knowing that, we couldn't figure out our x. Another way you could have done it is the big triangle. We know 105 and 52. You could have also figured out this angle by going 180 minus 105 and 52. That would work too. So there's more than one way, but you did have to find out one of these two angles before you could solve this triangle on the right. Yeah. Okay, so let's turn the page to some word problems. Okay, I would like you to try and draw this, please. Okay, let's talk about it in a sec. From the window of one building, so we have Sam in a building, and we have a second building. I always like to make my second building a little taller, but it doesn't matter. So Sam's in a window. Anywhere, you can put him in the middle, you can put him wherever. There's my Sam. Okay? So it says that Sam finds the angle of elevation to the top of the second building is 41. What is angle of elevation? Up. From what up? From the lasers that come out of your eyes or something. I don't know. So has to be a horizontal, so we have to construct one. Up to the top, right? That's the angle of elevation. So that would be 41 degrees. And then, where would you draw the angle of depression? Down to the bottom. From the horizontal down to the bottom is 54 degrees. Okay? And it tells us the buildings are 56 meters apart. The buildings are 56 meters apart. So, if this distance is 56 meters, what also is 56 meters? The horizontal in between here. Okay? Find the height of the second building. So what are you going to have to do here? Yeah, Joel? Are these going to be the same? No, because the angles are the same. If they were the same, then you could times it by 2. But instead, we're going to have to find one triangle, find the other triangle, and then add them together. Make sense? Okay. So we're looking for opposite. We have adjacent with the legs. So we're using tan. So tan is your favorite? It is actually. I like tan. Okay, tan of 41 equals. Yeah, opposite over adjacent. So in this case, it's going to be top one, 41. X over 56. So to get x by itself, what will we have to do? Because it's being divided, we're going to multiply the switcheroo. Oh, no, it's not the switcheroo. Yeah. Yes, if you keep 2 decimal places for both, then it'll be fine. But I like to use the exacts because then I know if it was a test, I know I'm getting the right answer. Exactly right answer. Okay, so 56, tan 41. 46.68. Yeah, see this one especially because of all the zeros. 48.68. Thank you. equals x. And then, okay, the other triangle, again, what are we going to use? We have the legs. Tan 54 equals opposite over adjacent. So, who's opposite of 54? Y over 56. So again, y is on the top. We are going to multiply both sides by 56. Okay. And then, yeah, we need to add these together. 77.08. So add those two values together to get our total height. Is plus, so I'm just going to 48.68005.732. And to the nearest meter. Okay. 126 meters, what do you need in this problem? An answer. So therefore, so this would probably be about out of 2 here, out of 2 here, you're adding, and your final sentence out of 1, so about a 5-mark question. Absolutely. Okay, but it might be different. I might say from, maybe another way I could word it is from a certain point in the middle, your angle of elevation is this much, your angle of elevation to the other side is this much. Yeah? Yeah, we're going to do the next point. That's a really important question. Okay, so therefore the towers are 126 meters apart.
So, the second tower is 126 meters tall.
I was talking about another type of example. It threw myself off. Okay, the second tower is, thank you. This is not a good quality recording. Sorry, guys. We're at volleyball. 126 meters high. Yeah, volleyball tournament. All right. Let's go on to the last question. Very, very, very good question. Also, test type of question. Oh, not that one. Did I scare you? Okay. Oh. Is that what yours says?
Yeah.
Oh, I want to give you a different problem. Okay, this is also a good test question. But I want to give you, but it's very similar to the last one, right? So can I give you?
Not really. You're trying to find out how much taller one is than the other.
Pardon me? Do you want to go through both of them?
I got an idea.
Okay, I'll tell you what. I'll come back to this one. So draw kind of like a line. I have 2 problems, so we'll come back to this one. If you want to listen and get it down, then you can. If you want to start on homework at that point, you can. So, but I do need to go through one other type of question that I don't know why I didn't add in. I'm sorry. Okay, so here's the problem. There's a helicopter. No, you didn't. Okay, so here's my helicopter. The helicopter, there's a chase going on. Okay? So there's a police car. Okay, siren's going off. Honey's chasing another vehicle, which is, I don't know, sports car. A motorbike, maybe. That's my race car. It looks like a duck. Streamlined, okay? It's a very streamlined vehicle. Okay, so the police car is chasing, okay? Now, the helicopter is 100 meters off the ground. 100 meters off the ground.
And it has like a straight line down from it.
Okay, and it measures the angle of elevation of the vehicles to the top of the helicopter. So the angle of elevation for the car is 20 degrees, And the angle of elevation for the cop vehicle is 40 degrees. Yeah. Okay, the question I have for you, what do you think the question is going to arise out of this? Yeah. How far apart are the two cars? That's what we're looking for. How far apart are the two cars? Okay, this is an excellent test question. Very excellent test question. All right. Now here's the thing. We always have to identify the two right triangles. What do you think students' biggest mistake is? They don't do that. They go to the first triangle, they find the hypotenuse, and then they treat this triangle right here as a right triangle. Is it anything close to a right triangle? Not even remotely close. So the question is, where are the two right triangles?
The far left one, and if you remove the line that's straight down there, then they're both.
If you remove this line here, you see this big right triangle. So they can share the right angle. So we have a small right triangle and then the big one, both using the same 90 and that 100. And it helps if you kind of draw them separately. So they are sharing 100 and the 40 and the 100 and the 20 degrees. So we have those two right angles, two triangles. So this 40, we're just ignoring this dashed line right there of that 40 angle. Okay, so how are we going to find this x? What would you have to do? No. Find the adjacent for both. So if we find this length here, I'll call this y. And we find this whole length here, I'll call this x. No, we already have an x, so z. Okay, so if I find this full length and this full length, what are we going to do to those numbers? Minus them. We're going to subtract them. I find this full distance from the helicopter, like on the ground, where it would be, to the car, minus the cop to there. Okay, so we're using which ratio if we have the legs? Tan. So tan 40, let's go through this pretty quick, equals opposite over adjacent. Who's opposite of 40 degrees? 100 over y. If y is on the bottom, we do the switcheroo. So y equals 100 over tan 40. Here's meter. Okay. You speedy Gonzalez. Yeah, you got it. I've never actually watched that. Is it a show? No? Oh. I've never heard of it before. Okay, 119.175 for now meters. So that gives us this little distance here. Now we need this full distance, the big triangle. So now it's the 20. Again, we have the legs, so we're using tan of 20 degrees equals opposite. Again, was 100 over this time z. So it's on the bottom, so we do the switcheroo. The old switcheroo. Old faithful. Okay, 274.7477. It's a lot of 7s and 4s. Okay, so now that we have these two values, we said we're going to do what? Subtract them. Just give me 2 seconds. So minus 119. I'm going to keep it exact. It's always better to keep it exact. Then you know you're not going to be off 1 or 2 decimal places. So the nearest meter, 156 meters apart.
Easiest way to do it though would be 100 divided by 10 minus 100 divided by 10, 40.
Yes, you can do it all at one step.
Just do it.
Yeah. Okay. I just want to set up this last question really quickly, and then if you'd like to work on your homework, you're welcome to. If you want to actually solve it, you're welcome to. Okay? So that last question here, two towers are 300 meters apart. So we have two towers. They're 300 meters apart. Okay? From a point halfway between them, okay, so halfway between the two towers, that's why it says 150 meters, we have two angles of elevation. Guys, can you just listen to this part? Or quietly get your stuff out, okay? Their angles of elevation to the roofs are 23 and 16. So 16 and 23. How much taller is one than the other? Okay, so to find the heights of them, we'll need to know the heights of each tower to find the difference in their heights. Now, if this is 300 meters and this point is halfway in between, how much is each of these lengths? 150. 150 and 150. So now that we know an angle and a side, do you have enough to find the height of each one? Yeah. So again, you have your legs. Again, it's tan. So you would set it up as tan 16 degrees, opposite over adjacent. And then tan 23 degrees, opposite over adjacent. That's a 23. Doesn't look like it. Okay, so to get y by itself and x by itself, it's being divided by a number, so we're going to multiply both sides by that number. So solve for those two heights. So 150, 10, 16. Oops. And 150, 10, 23. So those are the two heights of the towers. To get the difference of their heights, what would you do to that? So now that we know the two heights, 43 and 63, how would you get the difference in their heights? You minus the big one from the small one. So it's going to be about 20, if I said to the nearest meter. I don't think I did there. 21 to the nearest meter. So the difference would be 21 meters, right? We'd subtract 63 from 43. So that's how we would solve that. Okay, so your homework, 3 to 5 AC. Let me see. They're not all the same, but which ones? 3 and A and C, I mean? No, they're different types of setups. Yeah. What you can do. Okay, so I'll reduce it a little bit. So let's do. Okay, so page 118. So I'll just reduce that first part a little bit. So we'll do 3. Okay, when I still want to do 3AC, 4A, and 5A. So take off 4C. Okay, take off one of them. Take off 4C. And then let me just see your word problems. 8, 9. 8, 9. Those are different. Good. 11. 11's good. 14. You could take off 14. And then you still have to do 19.
No, we don't. Okay,
Let's do 14, take off 19. That's what we'll do. Okay? So you can omit 4C from that and 19. You're welcome. All right. Oh, they've been ordered. So they should be they've been ordered. I'm just waiting for the codes to come in. So they'll be in any day now. So bring in your $5 if you put your hand in, and I should get the code honestly early next week. Because they just email me them. So that shouldn't be that difficult.
Look at this. We had it all.
It's really nice. Where's the math?
Pardon?
Where's your math?
Oh.